Alright, welcome ladies and gents. We're going to talk about the mole some more, a little bit about Avogadro's number like we did in the past, add in some compounds, how they work with it, and especially molar mass. That's the big one here. And we're going to play soccer, at least as our example to tie it into normal life meeting chemistry. Alright, what are we going to learn? We're going to learn how to determine the molar mass of any element or compound, and we're going to explain the difference between what a mole and molar mass is. They sound similar, but they're really important to a scientist to be very distinct and different things. So we want to know what that is. Alright, so let's imagine that you've got a soccer game coming up. You're putting on all of your gear. We're going to start off with just you. Let's say for this example you weigh 127 pounds. But then you need to put on your shin guards. Each of them weigh 1.01 pounds. So it's going to be 2 shin guards, each at 1.01 pounds to add to you. Then your uniform, that's going to weigh 3.21 pounds. Then your socks to be put on, you've got 0.39 pounds for each sock. And lastly, you've got to put on your cleats. Each cleat, left foot and right foot, weigh 1.76 pounds. So now you got all your gear on, you're pumped up for your game. We need to find your new weight for the game. To do that, we need to add up all the parts of you and your uniform. So we're going to start with just you, add in 2 times each shin guard's weight. Your uniform by itself, because there's not 2 uniforms, there's not a left side and a right side. 2 socks, and then 2 times your cleats. So when we add up all those pieces, the total mass of you, the total weight of you, is going to be 136.53 pounds. We're going to tie in all those pieces together and how it ties into the mass of molecules and compounds next. Alright, so reminder, a compound is just elements being put together. So just lithium or just iron or just cobalt, they're just elements we know of in the periodic table. But if those elements bond together, then they become compounds. It could be 2, 3, 500 elements together. Some are small, some are large. It depends. There's some simple ones shown down below here on this screen of simple compounds that most of which we come into contact with fairly regularly. The oxygen we breathe in isn't actually the element oxygen, but the compound or the molecule oxygen, where it's 2 oxygens bonded together. Same thing with the nitrogen molecule. That's actually most of the air we breathe. There's a toxic chlorine gas molecule. Water is a molecule. Most people know its formula is H2O because there's 1 H and 2 O's, as you can kind of see by the picture down here. 2 H's, 1 O. Along with other ones that we're not going to talk about now, but we'll get into at some point. Okay, so we're going to look at how to get the molar mass of a compound. It's also called the formula mass by some people. Same idea. I just prefer to use molar mass, so we'll go with that one. Right, so you're going to want to know that the molar mass, or formula mass, is the sum of all the average atomic masses, that number we find beneath the elements on the periodic table, in that formula. So we're looking for the mole. If we have a mole of calcium chloride, CaCl2, we need to find its weight. That's basically what molar mass is asking, or formula mass. What's the mass of this formula if we've got a mole of it? Well, to do that, we have to take 1 times calcium's average atomic mass, or it's also called now its molar mass. So that's the number beneath calcium, element number 20 on the periodic table, rounded to 2 decimals, to get 40.08. Then we also have to have 2 calciums. This little 2 down here means there are 2 chlorines. This 2 means there are 2 chlorines here. There's no number beneath calcium, so it's just 1 calcium, 2 chlorines. So I'm multiplying chlorine's molar mass, it's an average atomic mass, times 2 because of this 2 here. When we do that, we'll add these pieces together to get the overall molar mass of calcium chloride. So that would be the mass, and it's the mass in 1 mole of that. So if we had those 6.02 times 10 to the 23rd atoms, that tons and tons and tons of atoms of this, that many atoms weigh almost 111 grams, which is not all that heavy. It's way less than a glass. But that's showing you again how small atoms, elements, and compounds are. But we need to know how much a compound weighs for a lot of things we're going to do next. Yeah, so grams per mole is always going to be your units. It looks like it's missing an E. We'll get to that in a little bit. All right, so it says practice. Really just going to show you that these come out to different masses. Like aluminum chloride's got a mass of 133.33 grams per mole. Sodium hydroxide's got a mass of 40 grams per mole. That one comes out awfully round. Calcium phosphate here, these little 3's and parentheses and subscripts will get more complicated. We'll go through how to do those later. It's got a larger molar mass. Carbon, nice and simple. It's just the number beneath it on the periodic table, 12.01 grams per mole. Okay, so how do we do this? So we write a chemical formula by looking at the formula itself. That little subscript we talked about tells you how many of the atoms there are directly to the left of it. So there's 2 chlorines, not 2 calciums, just chlorine. The symbol is going to be what element it is. Remember that every capital letter you get is a new symbol. Lowercase letters always go with the capital letter to their left. So that's why we know A is not its own element. CA is, because C is the capital letter. Then this capital C starts the new one with a lowercase l. So we know there's one calcium, 2 chlorines in this molecule. So then we need to use that average atomic mass on the bottom to find out what it is. So on these pictures, hydrogen's average atomic mass is 1.0079. We can round it to 1.01. Carbons will be 12.01. Now remember that when we use the units of grams per mole, per means divided by. So when we did conversions earlier, we had a top unit and a bottom unit. That's going to come back into play. So you might want to get used to writing mass, like down here in the bottom left, of grams divided by moles. And the other weird thing over here, moles gets abbreviated to mole, which is MOL. Chemists get really lazy and just take off one letter, but you can't shorten it any more than that, because if you make it just M, that's meters, and grams per meter is a whole different thing. So if you want to put MOLE or MOL, either one's fine, but it's got to be one of those two. Okay, how to round in the periodic table. So just to make things easier, if you're working with me, round to 2 decimals will make your life much simpler. So if we're looking at lithium, it goes 6.9412 grams per mole. Remember, we're looking to round this second number here. So we look at the 3rd decimal. If this number is 5 or greater, this second number will go up. Since it's not, we just keep 6.94. For magnesium, though, it's 24.305. That 5 is 5 or larger, so this 0 is going to round up to a 1, 24.31. And oxygen, same deal, 15.999. So this 3rd 9 makes this 9 round up, which makes this 9 round up, which makes this 5 round up, which means we get an even 16.00 grams per mole. All right, here's some practice you guys can try if you think you're ready. So if so, go ahead and hit pause, and then unpause when you're ready. So you're going to try and find the molar mass of these compounds. H2O, water, and magnesium hydroxide, or Mg in parentheses OH2. You can guess what that parentheses means. If not, I'll show you here in just a second. All right, so for water, we have to figure out how many of each thing there are. So there's 2 H's, because that little subscript told us there's 2 of the thing to its left. So 2 H's, nothing here, which really means there's a 1 there. Just like if you put an X in math, that means 1X is the same as X. We don't put a little subscript if it's just 1. So there's 1 oxygen times its molar mass from the periodic table, 1 times 16, and then 2 times hydrogens, because there's 2 hydrogens, gets us these totals for each element. Add them together, just like you did for all the pieces of your soccer uniform to get the total mass of the entire molecule, the entire person with its outfit on, we'll do the soccer analogy. Magnesium hydroxide gets a little trickier with these parentheses. It's like math. You have to distribute this 2 into the parentheses. So this 2 gets multiplied into the H and into the O. So there's 1 Mg, 2 O's, and 2 H's. Now, we'll get to this later. Technically, it's not MgO2H2, but for now, you should know how many there are. So as long as you can figure out that that 2 multiplies into the parentheses, but not to the magnesium, you'll be okay. Then we add up the mass of 1 magnesium molecule, 2 oxygen molecules, and 2 hydrogen molecules, atoms, and they add up together to make 58.33 grams per mole. If you got those on your own, awesome. If not, that's okay. We'll get more practice here in just a second. Okay, here's that fun calcium phosphate one. Now there's subscripts outside the parentheses on the left, outside the parentheses on the right, and inside the parentheses. So that 2 has to be distributed just like the last one was to the P and the O. But since this O already has 4, we have to take 2 times 4 to get 8 oxygens and 2 phosphoruses. So we take the mass of 3 calciums, mass of 2 phosphoruses, and 8 oxygens to get that grand total we saw earlier of 310.18 grams per mole. With or without the E, up to you. Okay, mole or molar mass. So these are 2 terms that are going to sound similar, but it's important to know the difference. So a mole is just a number. We talked about just like a dozen. A dozen, a baker's dozen, a mole, they all just are equal to a number. They represent an amount of stuff. That's how many things a mole represents. Like we said, a dozen is 12. That mole is 6.02 times 10 to the 23rd of anything. Usually atoms or molecules, but you could talk about anything in terms of moles. So in chemistry, we're using it for, just said, the atoms and atoms and molecules. Okay. So molar mass, on the other hand, it's the mass of 1 mole of anything you have. That's what we've been doing for this whole time. So if you've got a mole of something, it's going to weigh this much, have this much mass. So we've been doing it for like calcium chloride or oxygen or calcium phosphates, but you could have the molar mass of paper clips. You just have to have a mole of them, which would be insane because it wrap around the world 400 trillion times, but you could. It's how much something's going to weigh or have a mass of if you have a mole of them, if you have 6.02 times 10 to the 23rd of that object. Hopefully that makes sense. If not, let's chat. Let's figure it out so this makes sense to you, because something I want to make sure you understand through and through.